bother me if I talk like this. Okay. So, my name is Alexandra and I work for Knowit Reactor Solutions in Bergen. And today I will be scratching a bit the basic concepts of in functional programming. I will start with give the definition of functional programming, and according to Wikipedia, in computer science, functional programming is a programming paradigm, a style of building the structure and elements of computer programs that treats computation as the evaluation of mathematical functions and avoids changing state and mutable data. It is a declarative programming paradigm, which means that programming is done with expressions or declarations instead of statements. Now in this presentation I will walk through some of the most important concepts in functional programming, and those are recursion, immutable data, higher order functions, pure function, function composition, currying, closure, just to walk through. So starting with the most basic and important concept in functional programming, the function. The function is a construct that will produce an output given an input. That's quite basic, which means that it maps an item from one set to another set. In functional programming, we use pure functions. We should have pure functions. A pure function is a function that returns the same result given the same arguments, and it should not cause any observable side effects. And in my drawing, I would assume that in that box there are no side effects, like writing to a console or in a database or in a file. It is impossible, in my opinion, to completely eliminate side effects, but in functional programming we should aim to take them as much as possible. Jumping forward to higher order functions. These are functions that work on other functions, meaning that they take one or more functions, function or argument, and can also return a function. There's another terminology here, first order function, and this relates only to computer programming languages that treat function as a variable. With the higher order functions, we can also talk in terms of mathematics and yeah. Function composition. Now, to achieve function composition, we use higher order functions. And function composition is an act or a mechanism to combine simple functions to build more complicated ones. And in functional programming, like the usual composition of functions in mathematics, the result of each function is passed as the argument of the next, and the result of the last one is the result of the whole. We want to encourage function composition because it helps us decompose, break apart. And breaking apart problems helps with the usability and maintainability of the code. Recursion. The recursion is a programming technique. This involves the use of a procedure or subroutine, a function or algorithm that calls itself in a step until it is met a terminal condition. With a recursion, we practically have a problem and we break it and break it and break it until it's very trivial to resolve. We can have like two types of recursion. That's direct recursion and indirect recursion. Direct recursion is when a function calls itself, and indirect recursion is when we have two functions that call each other. The closure. There are many definitions of closure, but I've chosen to give one of Kyle Simpson, which seems more simple. Closure is when a function remembers its lexical scope, even when the function is executed outside that lexical scope. Which means that the closure is a mechanism by which an inner function will have access to the variables defined in its outer function lexical scope, even after the outer function has returned. Here I have tried to make a drawing with the scopes, and we have the global scope that knows only about the constant global scope variable. The inner scope inside the global scope will know about the variables inside the outer function and about the variables in the global scope. Will not know anything about the variables in the closure in the inner function. And more deeper, the inner function will know about everything. That's the closure. When we talk about function programming, we also talk about three variables, and we talk about the environment. So what is outside closure is the environment, and the variables that are outside closure are called free variables. Currying. Currying is the process of taking a function that accepts n arguments and turning it into n functions that each accepts a single argument. When we talk about arity, that means that the arity is the number of arguments that a function can accept. So currying is more like not give me five items at once, but give me one and let somebody else provide the four later. So in my example, the function add, instead of calling the function add with three parameters, a, b, c, I call the function add, which returns a function that takes b, which returns a function that takes c, and then we have the return a plus b plus c. And now currying works hand in hand with closure. And we can see that a and b are variables from the environment. There are three variables for the function that takes c as an argument. Thank you.